Hello everyone, welcome back to my YouTube channel. My name is Parvinder, and in the series of Java design patterns, we are going to discuss one of the most popular and frequently used design patterns, the Singleton Design Pattern. Whether you are working on desktop applications, web applications, or mobile applications, understanding the Singleton pattern is crucial for managing resources efficiently. So let's get started. So the Singleton design pattern is a creational pattern. So as in my previous video, I mentioned like there are three categories of design patterns. First one is creational design patterns. Second one is structural, and third one is behavioral. So here we are going to discuss Singleton design pattern, which comes under creational pattern. So basically creational patterns deals with the object creations. So how we can create the objects. So single pattern is one of the creational patterns. So that ensures a class has only one instance and provides a global point of access to the instance. So this is specifically useful when we need to control access to a resource like database connection or a connection configurations or configuration files or loggings. So, and we want to make sure that only one instance of the resource exists throughout the application. Let's take real world example. Imagine we have a single coffee machine in our office, right? To ensure that no two people use the machine at the same time, and to maintain that order, we make sure that only one person can use the coffee machine at any given time. The singleton pattern works in a similar way. It restricts initialization of that only one object of a class is ever created. So throughout the application, so we will be having a single object of a particular class which is following singleton design pattern. So let's jump into the coding side to understand singleton design pattern in details. Let's create one class and its name is singleton. Okay, so the very first thing, so we need to declare the reference of this class, which should be static and private in nature. So private static class reference. So private static singleton, let's call it instance, or we can call it singleton. I think instance is better term we can use. Second thing, we need to create private constructor just to restrict the outside initialization. So private singleton and empty constructor. So just to restrict any initialization. And the third thing, we need to declare one static function that will be returning the instance of this class. So we are using public static singleton get instance method. So this function is to method to initialize object of this class. So here we will be checking if instance equal to null. In that case, we will be creating new instance. Or if the instance is already initialized, so this condition will not be working. And finally, from this method, we will be returning the instance. So this is the very first example of singleton design pattern. And we can, let me make method here, public void show message, and let me pass some message here, and finally I will be printing this message. Okay, now uh, so we have declared the reference. So in this declaration, so we have used private access modifier and static. So we have declared this private because we don't want this instance to be accessed from any other class outside of this class. And we have made this static because we don't want to make this instance a part of any object. So the static variables are always part of the class, not the part of any object. And this private constructor just to restrict any kind of initialization of this reference. But we need to make sure this object should always be initialized inside our static method, so which is ultimately returning the instance of that this particular class. So for that, first we are checking if the instance is null, only then we will be creating the new instance. Otherwise, whatever is previously initialized, we will be directly returning that instance. So this method will make sure throughout the application we have a single instance of this class only. So this is the very first and basic uh, example of singleton design pattern. So one thing I would like to add here, so this particular initialization is called lazy initialization. Because in this initialization, so whenever this method will be called, only then this instance will be created. So this kind of implementation for this singleton design pattern is called lazy initialization. So in this method, class is initialized only when it is required. It can save from initiating the class when you don't need it. Generally, lazy initialization is used when we create singleton class. So most of the time you will be seeing this type of code. We have another category which is called early initialization. So in next example, we will be looking into that. But this is the lazy initialization. Move on the another way to create singleton pattern. So what I do, let me make one package here. Okay, let me make one main class, and here we have main method. So let's create object of singleton class. So singleton equals to new singleton. So outside of the singleton class, I am trying to create the object, but the error here says singleton has private access in singleton. So means whatever the constructor we are trying to call, that is private in nature. So we cannot initialize the singleton object this way. But we have a static method that is get instance. So we can call this to get the object of singleton class. So let me call singleton dot get instance. So this way we got the object, right? And for example, I am naming this singleton1, and we can call singleton1 dot show message hello. And let me create another object, and I can print some message world. Although it seems like we are creating two instances. So here for singleton 1 and singleton 2. But if we see in the class singleton class, so in get instance, the very first time when we created first instance, so this instance reference is initialized and returned, right? And one second time I try to created another object. In that case, so this if condition validated, like instance is already initialized, so that is not null originally, right? So in that case, so only the already existing instance will be returned. So this way we can see both these singleton 1 and singleton 2 references pointing to the same object. So let me run this first. So we can see both the outputs. And here I can do one thing just to make sure like singleton 1 and singleton 2 are the same. Uh, if same object, okay, so here singleton 1 equal to singleton 2. So if those are pointing to the same object, so they will be returning, this expression will be returning the true, otherwise this expression will return false. So you can see if same object, true, right? So this is the first example of singleton design pattern, or we can say this is the first way to creating class by following singleton design pattern. So let's jump onto the second example, but let's create package singleton. So dot it's lazy initialization. So I'm moving these classes here, and let me create another package eager. So basically now we are making another example of singleton design pattern, so which is eager initialization. So let me create class singleton. In eager package, so here first we need to declare the reference of this class, and let me initialize here right away. And similarly we have a private constructor just to restrict the initialization from outside. And finally we have get instance method where we are returning the instance of this class. Now, so as per this way of making singleton class, so here you can see we have initialized the static variable at the very beginning. So in this case, JVM executes a static initializer when the class is loaded, and hence this is a granted to be thread safe, because this instance is created before starting any of the threads, right? So always when some thread will be calling get instance, so it will be getting the same instance which is already created. And I would like to add one thing more. So the way we have created this singleton class, so class is initialized whether it is to be used or not. The main advantage of this method is its simplicity. So we initiate the class at the time of class loading. Its drawback is that class is always initialized whether it is being used or not. But if we consider the example of uh, our lazy initialization, so here the reference will never be initialized until we call get instance. So in this way, so we can say lazy initialization is better choice as compared to eager initialization, but both the concepts has their own benefits and drawback. Another way to make class singleton is to declare get instance as synchronized so that the initialization would be thread safe again. So let me create another package here. So we can say thread safe, and here I am creating the class Singleton. So here in this class we have the reference and then private constructor, and we have the method Singleton instance. And just to make this function thread safe, so we are declaring it synchronized, and inside this, if instance equals to null, then we are initializing this, and finally we are returning this. So this is one way if we are working in multi-threaded environment, so we can use this approach so that two simultaneous threads cannot access this directly. So if one thread has locked this method, so until its execution is completed, so another thread cannot enter into this block. So this way we can make this initialization thread safe. But the problem with this method is using synchronized every time while creating the singleton object is expensive and may decrease the performance of your program, because until one thread is busy in this block, so another thread will have to wait to access this method. So this way, this is the drawback of this method. So finally, we have the last most efficient way to create singleton design pattern, and also it would be the thread safe one. So let me create, or I can do one thing, we can make the changes here only. So rather than making this complete method synchronized, so what we can do, so we can just synchronize a block where we are initializing. So here we can declare a synchronized block, and inside block we can just check if the instance is null, only then we need to create the instance. So this is the most safe approach, where we are not synchronizing the complete method, but we have synchronized the block where we are initializing the object. So this is the best way we can use. So here now we have multiple approaches for this singleton design pattern. The first one is lazy initialization. Let me correct the comment. So first way is lazy initialization. Second, we have eager initialization. So we can put comment here as well. So on some books it's called early initialization as well. So I'm mentioning both eager and early initialization. And the third way is to make it thread safe. So we can either make the whole function synchronized if the functions are complex in nature, or the functions contain a lot of lines of code. So in that case, so we can use the synchronized block to initialize the instance. So this is all about the singleton design pattern. To sum up, the singleton design pattern is a powerful tool when we need to ensure that only one instance of a class is created and used throughout your application. It's specifically useful in resource management scenarios like database connection, logging, or any configuration settings, right? So if you found this video helpful, Don't forget to give it a thumbs up, share it with your friends, and subscribe to this channel for more in-depth coding tutorials. We will be covering more design patterns in this series, so stay tuned. Thanks for watching. If you have any questions or suggestions for future topic, drop them in the comments below. Until next time, keep coding and keep learning. Thank you.